thank you very much for introducing me, Rosie. Like Rosie said, I'm the exhibition director for the exhibition that's accompanying our conference. And just to kind of give you a bit of context in the exhibition, unless you haven't seen it before, it's been developed through Mozilla Hubs. It's a virtual reality exhibition. You can access it with a VR headset. And you actually start and end in the same room. And that room essentially then branches off into different timelines. And we have an exhibition guide that actually helps you to locate all of the different portals and routes. But yeah, everyone is welcome from our mail network, from the audience, to actually contribute to the exhibition by building their own hub. And we're also inviting people who are being exhibited right now to completely change their hub and really kind of make the exhibition grow, because it will be on throughout the entire year as an experiment. Okay, well, I will start sharing my screen now. Okay, right, so my paper is called Recursive Alterity, Experiments in Virtual Reality and Machine Learning, and it's really an extension of the work that we've been doing over here at the UCL Multimedia Anthropology Laboratory. In search of a method, UCL Multimedia Anthropology Lab's virtual reality exhibition and the upcoming machine learning experiment form part of an ongoing effort to assess the ontological turn in anthropological research. However, it seems like the pursuit of alternative systems of thought through ethnographic inquiry can sometimes be hindered by the darkness of relativity. While Holbrad and Peterson intend to depart from other ontological turns, Bruno Latour's active network theory is undoubtedly an early conceptual device that has caused the ontological turn to inherit a set of distinctive ideas. One of the characteristics is a certain flattening of ontology, both in terms of weight and indicators of local/global scale. The formulations that attempt all observable substance irreducible to each other can therefore be viewed as an invitation where really anything goes, which leads us to the question, what qualifies as a metaphysical system? And once we do find that quality, how can we negotiate these different ontological articulations? Well, it's important to radicalize doubt and to ensure a cumulative rather than universal compounding of knowledge. This exercise of comparison does not make explicit recommendations at the level of empirical tools and the treatment of metaphysical substance. In trying to navigate the equation of differential relations, emerging technologies such as virtual reality and machine learning prove to be particularly useful. These tools generate data points that aid in assessing a given epistemological situation, capturing the sought after variance, which Rafaela introduced at the beginning of the conference, through quantifiable, accidental, and sometimes even opaque means. Alterity has been given a lot of presence and a lot of weight in this methodology, for it is a crucial element of contradistinction and the resulting contingency. However, it has been defined as a kind of reflective estrangement, a self-othering, engendering a game of boundaries and impossibility. For example, I know that I can never experience what it is like being a given object, such as a table or a chair, or believe in another community's cosmogonies. Nonetheless, you can imagine what it could be like to understand these conditions. Manigler calls these second-degree misunderstandings, forming part of his 4-step recommendation for applying the comparative method in anthropology. This is exactly the way we can radicalize and almost celebrate doubt. In order to further elucidate the mechanics of this methodology, we have to consider departing from the assumption that anthropology is inevitably a science of oneself or a science of the human self. We ought to locate the instrumental other, where recursive patterns of equivocation operate at the level of multimedia technology. Algorithms are inherently recursive, creating sequential and simultaneous operations that multiply, differentiate, and integrate input values in numerous and complex ways. The question is, how can we tap into that other algorithm, where its operation is not immediately obvious or determinative? Quite interestingly, Latour shies away from the possibility of an engineered contingency, claiming that a technical network is only capable of rendering final and stabilized states of an actor network. We need to perhaps maybe unpack these mundane processes of computer intelligence. My experimental practice with three-dimensional rendering and machine learning has been a process of uncovering somewhat overlooked abstract utterances, which is, I argue, where recursive alterity lies. The virtual reality exhibition and machine learning experiment is a project of engineering contingency to find technological alterity. On the exhibition as an abstraction rather than documentation of ethnographic material. Exhibiting research does not have to be subordinate to the act of generating it. In this vein, like I said, our exhibition is not a culmination of the conference, but rather its extension in the form of an experiment. This is exactly why we allowed the exhibition to take on an organic form. The process of creating it was decentralized, and the rooms don't really share a common visual language. I purposely didn't disclose the themes I followed to group the rooms into the three timelines that you can take from a starting point, allowing the visitor to build their own system of classification and difference. Like I said before, I would also like to invite you, the audience, to contribute to our network of Mozilla hubs by building your own and encourage existing exhibitors to ask for changes and developments. The exhibition does not have to look the same way it does after a few months. Recursivity is versioning. Beyond curation, composing ethnographic material into a digital space such as virtual reality introduces additional assumptions that may create epistemological stagnations. Virtual spaces have been prone to ontological attacks amidst the sea of the real or the physical, where its position as a palpable source of observable phenomena is undermined. A framework where the digital occupies its own materiality, a digital reality matrix, is far more productive in trying to locate the potential of multimedia tools in unexpected knowledge production. Disseminating or translating ethnographic material from multimedia tools is never an innocent act of documentation. Instead, contemporary technologies add a layer of computational procedures that aren't inherently intuitive and therefore deserve our attention. The difference between a JPEG image on a screen and a JPEG that has been inserted into a virtual reality environment is not immediately obvious. However, on a computational level, the two take on very different graphics pipelines. The treatment of Zlata Michetina's work for the exhibition illustrates this well. Michetina's work is originally a series of collages that consist of zoom screenshots and visual manipulations using Photoshop. I have used these photographs as textures for creating a model of a primitive plane in Blender. Translating a bitmap image into a three-dimensional object generates additional coplanar, that is, existing on the same plane, vertices and faces. To begin with, Blender multiplies the existing data and reverses the image on the other side to make it continuous and non-orientable. We can also encode other pieces of information that aren't the default coplanar data points. I used the subdivision surface modifier, otherwise known as a polygonal mesh subdivision, to perform an advanced tessellation of polygons. This allowed me to sculpt and morph the object's vertices so that they can be projected into space. In this way, what was initially an ethnography on surplus time during the COVID-19 pandemic and furloughed populations became an implosive series of mathematical interpolations where an ethnographic object became something otherwise. Rendering any objects in a three-dimensional space, even if it is seemingly flat, which is a deceptive assumption, involves a rebirthing of context. For example, by default, a bidirectional scattering distribution function is set to determine the way light is scattered by an object. Viewing ethnographic material that has been translated into a digital object as equivalent or final overlooks the projection of new mathematical and graphic systems underpinning it. One of the early prototypes for the exhibition was developed in Unity, where, unlike Mozilla hubs, I could use using high-level programming languages such as C# for collision detection. There, the application of a rigid body engendered an unprecedented control of physics and causal reactions. For example, if I was to remove the conditional statement is grounded, the pill would actually be able to disobey physics and continually go up and up into air every time you press the space button. Or if I were to change the multiplication in the rigid in the vector 3 up line, you could actually kind of go up much. You can make the jump go much higher, regardless of what the weight of the model is in a given system. Although Mozilla Hubs lacks this capability, we have deleted the walkable ground plane where possible to be less prescriptive in the movements that an avatar can make. The question is, how can we utilize this combination of control and contingency for anthropological knowledge? Well, this is a question targeted at individual anthropological or collective anthropological practice. I've managed to get another interesting insight while working on creating some three-dimensional faces for Funa Ye. Ye's work is based around Meitu, which is a Chinese beauty filter app. And in trying to dialogue with her practice on a curatorial level, I created some three-dimensional models out of beautified. Well, I asked my friends to use some Instagram filters out of beautified faces. And when doing some texture mapping, I stumbled across uncanny deconstructions of the human face, unraveling a skeleton of vertices, and some of them are actually quite terrifying. The virtual reality exhibition borrows this language and allows you to enter these models from the inside, where the laid out vertices are assembled into these concave structures. That moment felt like Manigliar's second-degree misunderstanding, where a calculated technological interaction rather than a conceptual one became an act of comparative metaphysics, which in a very humble way assesses two instances or more and makes commensurate connections between them in forms of understanding or remixing anthropological material. Recursivity is rendering an object into a three-dimensional space. On machine learning and its treatment of data points. Mathematically, many of these graphic manipulations involve some sort of interpolating pixel values between vertices. The generation of specular information, such as in the BSDF function that you've seen before, relies on estimations of surface normals that are then fed to computational algorithms. Every additional piece of generated information is therefore alterity, destabilizing the object, the digital object as we know it, through quantifiable and sometimes visible means. These techniques of tessellating existing information therefore share lots of characteristics of machine learning, where data points seem to be conjured out of nowhere. At its most basic, however, machine learning is a predictive model based on statistical analysis. It fills knowledge gaps, and this is what makes it an enticing collaborator for the treatment of ethnographic material. The black box nature of certain types of training algorithms, such as unsupervised machine learning, creates the effect of agency being handed over to the substance of algorithmic alterity. Yet there are certain factors that may complicate its untainted role or, kind of given role of discovering the plurality of or unexpected outcomes, which is something that I would like to consider as part of MAO in the upcoming experiments. Manigliar makes a very strong distinction between the variant and the variable, which indirectly elucidates why Latour has some preconceptions on engineered networks. While the existence of a variant is defined entirely by equivocation and contradictions, a variable, according to Manigliar, is a graphic substitute for a set of values that are in a determinate relation to another set of values. Artificial neural networks rely on these variables, which independently digest inputs for an act of comparison by the discriminator. The result is the tuning of parameters, sometimes referred to as weights, and backpropagation to achieve a desired output based on the training set. Therefore, is machine learning truly a collaborator capable of engineering contingency? There are several other obstacles that we have experienced so far in trying to suit machine learning to our needs and conceptual formulations. The computing power required to build your own generative adversarial network is so demanding that it requires you to connect to remote graphics processing units through platforms such as Google Colab. Moreover, in order to avoid common GAN failures, such as a mood collapse, you're advised to gather as large of a data set as possible. This leads to inherently asymmetric data flows where smaller contributions become subordinate to existing realities that are unfairly homogeneous and actually quite hard to break from. Thoughts for the future. In reality, the difficulties posed by machine learning actually invite us to find novel ways of interacting with these emerging or reimagined technologies. Certain pre-trained and accessible models, such as StyleGAN, are made for specific outcomes, such as generating a believable human face. However, what if we were to go against the pre-programmed functionality of these algorithms and use them for something else, something otherwise? There's also an interesting moment of abstraction when a machine learning system is learning to see, so to speak. As part of our experiments with StyleGAN 2, we were able to see elements of its iterative nature as it was generating fakes. That is, before our GAN collapsed due to a small data set. These underdeveloped manifestations provide yet another way to grasp the otherwise sticky alternative metaphysical systems that the comparative method is advocating for. We have seen and impact the capacities of three-dimensional rendering and obtaining previously non-existent data points. Although this happens on a very graphic and technical level, these experiments may sometimes lead to conceptual manifestations. In this way, we can engineer contingency. Machine learning also has the potential to be readapted. Most importantly, we need to continue locating alterity beyond ourselves in unexpected places, such as computational technologies, in order to further explore ways of undocumenting and abstracting multimedia anthropology. Hopefully, as anthropologists, we can make more informed decisions about the technologies we use, and through that, strengthen our purposes. Thank you very much for listening to my presentation. As I mentioned earlier, the audience is welcome to contribute to our exhibition. And since the machine learning experiment is an ongoing experiment, I would also like to invite anyone who wants to be part of it. You can email me here. But yes, thank you for listening.